Hello guys, my name is Yusuf. In this video I'm going to show you how to build your own object detection model using TensorFlow's object detection API. This project is my graduation project and I'm going to explain how to build your model step by step. At first, go to the TensorFlow's models repository and download all of these files as zip file. When your download finish, go back to my GitHub repository and here, yes, again go to the TensorFlow's repository by clicking this link and download faster RCNN Inception v2 CUDA. After downloading this model, go to the local disk C and create a file named TensorFlow1, just like here, local disk C and TensorFlow1. Name it as like this. Extract your model's master file here by clicking this and name this file as models. Okay, when this process finish, go to the research file inside the model and find the object detection file. Yes, when you came here, go back to the TensorFlow1 file and just copy your model here and paste it. After copying your model here, extract models files. It should be something like this file. Done. Of course, your models file won't be seen like this at first. There will be no such files like this. After all of these steps, you have to go back my repository and download one of these object detection.rar or object detection.zip. Okay, just download one of these. Okay, it's not a large file, it will be short. Just download one of these. Okay, now again copy this file into your object detection file. After copying this file, extract the files inside it by clicking this. After this step, let me delete this and this. You don't delete this file, by the way. After these steps, your file should contain something like this. I mean, your file should look like this. There should be an images file, inference graph, generate TF records, object detection image, object detection video, and object detection webcam. And of course there is a training file. You should have a training file here. Oh yes, okay. Now after these steps, go back to my GitHub repository. Yes, yeah, I have shared the image here. Your file should seem like this. Whatever. After these steps, go to the anaconda.com, download anaconda. Where is it? Download now. I'll download it for Windows. After download is finished, open command prompt and type this command. Where is it? It's here. CUDA creates TensorFlow-1 on Python 3+6. This command is gonna create a virtual Python environment on Anaconda, and we are going to work in this environment. We are going to do our whole things in this environment, so do not forget the name, this name, TensorFlow-1. It will be your environment's name. Okay, do not forget this. Yes, after step 5, let's jump to the step 6. In this step, we are going to install all the Python libraries we need for object detection. You can find the libraries in my GitHub repository in 6th step. Okay, first download TensorFlow for GPU or whatever. If you want to work with CPU, you can download it from CPU. You don't have to write this. You can find another command, like you can Google it like this: how to install TensorFlow CPU, or how to install TensorFlow CPU for Anaconda. Yes. Or Anaconda TensorFlow. Yes. You can copy this. Yeah, by the way, I have already have this virtual environment on my computer. To activate your virtual environment, you need to type this: activate TensorFlow-1. Tick tock, tick tock, tick tock, tick tock. Yes, it took so long. I know. When your virtual environment is activated, it's going to be seen like this. There is a parenthesis inside it. There is a string named TensorFlow-1. Whatever. To build your libraries to your computer, to build Python libraries to your computer, command your commands. Type your commands here. Sorry for my bad English. Like this, and press enter. Okay. After TensorFlow, other library is protobuf library. CUDA install Anaconda protobuf, just like this. Okay. Then PRP install pillow. Then PRP install XML. Don't forget to press enter here. I already have these libraries. This is why I don't press enter. And PRP install Jupyter, PRP install Matplotlib, and PRP install Pandas. The most important library, one of the most important library, PRP install OpenCV-Python. If you get any errors while downloading this library, just try to download it from another source. You know how to Google it, how to install Python, blah 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 library. Okay. So now let's jump to the other step. Let's close this. Yeah, guys, this is an important step. Now we are going to set our Python path. Just copy this code and paste it to command prompt. Set Python path and click enter. Do not forget these points. Whenever you activate your TensorFlow-1 or whenever you open your command prompt again, you need to set your Python path. You need to write this comment again and again and again. Okay, don't forget this. Okay, right here there is an image how to do all of these. I've just told. By the way, you can change your directory here. It's up to where your file is. My files are in local disk and TensorFlow 1. You can change this directory according to your own directory where your models file is. Okay, do not forget this. Now, yes, step 8. Go back to your command prompt. Type gd cd and go to your C and go to your TensorFlow 1 file and go to models file and go to research file. In research file there is a command you have to write to compile the protobufs. Just type these comments. Yes, all of these are comments. Copy all of these. Okay, copy all of these and paste it here and press enter. I don't know why I got 0 and you won't get 0, don't worry. Yes, I already compiled my protobufs. Okay, you will not get this error. And to execute the setup file, you have to write this in your command prompt in your TensorFlow 1 models research file by activating TensorFlow 1 environments, just like here. Okay, just copy and paste these commands here and press enter. Okay, press enter and then copy other commands and press enter again. Okay, I already did these setup steps, so I'm going to close this command prompt and open another command prompt, and I'm going to show all of these again. At first we are going to see, then TensorFlow 1 file, then research, models, then research, then activate TensorFlow 1 virtual environment, then setting your Python path by copying this code here and pressing enter. Okay, now step 10. In this project the results are here. As you can see, this is Turkish language, by the way. This is how our model finds and classifies the traffic sites. I got my own datasets. I collected it from Google Maps. Let me show it. Models, research, object detection, and in this image file, the train and the test sets. In my train sets there is 3,276 items. Half of these items are photos and the half of these items are their labels as XML file. Same for the test directory. Half of them is JPEG files and half of them is XML files. Okay. Now I'm going to show you how to prepare your own datasets. Watch these steps carefully. Okay, watch these carefully. So yes, now I'm going to show you how to label your images. Now I'm going to create a sample directory and I just copy this one of these photos or two of them. Okay, I'm going to copy these and I'm going to create a sample label directory. Paste yes, the program, where is it? This label imager, yes. Label imager is a photo labeling program to help you label your own images, and it's creating an XML file to hold the photos label information. I'm going to show how to use it. Select your folder or photo, doesn't matter. As you can see, there's a traffic sign. I'm going to create a reg box and select my traffic sign, and I'm going to write a class name for it. Do not forget these class names. We are going to use these class names soon. Okay, no entry. Then control save and save. Then jump to the next image and create another reg box again and another class member, or you can create classes like this. Do not forget how many classes you have and do not forget their names. Okay, or I don't know, it's up to you. Your class names are your own ideas, I don't know. Do not forget these two names for now. Okay, Control S and save it as XML. Now, as you can see here, there is photos and their XML labels, as we have here in our test dataset or in our train dataset, photos and their XML label informations. Okay, now after this step, you know how to create your own dataset from this moment. I can delete this, I do not need this anymore. Now where is it now? Yeah, by the way, this is my own dataset. I collected it from Google Maps. You can download it from my repository. There is a drive link, test set and train sets. As you can see here, this is my own dataset. Okay, now we are going to use these XML files. These XML files are our labels. Okay, do not forget this. Now, images, yes, in this file. By the way, at first these two CSV files won't be in your object detection folder. Now we are going to create these two files by writing this. At first, do not forget to activate your TensorFlow virtual environment and setting your Python path by writing this code. You can find this code in my GitHub repository, and using cd direction commands, go to the TensorFlow models, research and object detection, then write this command: Python XML to CSV.pa. Okay, this is going to create these two CSV files here. Those CSV files are containing the information of photos name and their information of what? Information of the objects and objects location in the photo. Finally, reiterate, these are not important. Class is important. Here x max, a max. These are the pointer of these two things. These four name x min, y min, x max, a max are the pointer of the objects. Now, in step 12, there is the object detection. Yes, there is a file named generate TF record file. Open that file in a text editor. There is a function class text to int. In this function, we have to change those code pieces. Okay, for example, you have to write here how many classes you have and their names. For example, we created two labels. You remember? No entry and parking or IDC. Okay, you have to modify this function according to your own dataset. I mean, how many classes you have to write these numbers according to it, and you have to write their names right here. Okay, in my datasets I got two classes, two traffic sign. This is why I have four number of classes and their names like this, as you can see here. Now close this tab. By the way, I explained the things that I'm telling you now here. Where is the other step? This. After this step, in step 13, where is it? Yes. Go back to your command prompt and type these commands. At first, type this. This is going to create a train record inputs. Okay, type this and press enter. Then type these commands, and this is also going to create a test record inputs for your model. Type these commands and press enter. Okay, whatever. Step 14. Go to your label map pbtx. The label map pbtx is here in training folder. If you don't have this file, just create this file, name it label map.pbtxt. Okay, edit this file. This is similar to your generate TF record file. There are IDs, there are items, their IDs and their names. This is about your classes and their IDs in the TF generated file. It should be seen like this. For example, I have I have four class. This means 1, 2, 3 and 4 different ID, 4 different name. It should be similar to like this: 4 different class name and 4 different number. Okay, you have to set this file like this. If you have more than 4 class, you can create another item like this. For example, class 5. Okay, it's up to you. Okay, yeah, I will explain this. In 15th step, we are going to make some changes in the file? In the object detection directory, training directory, Thesis, Inception v2 pets.config file. Open this file. Yes. Yeah. In line 9. In line 9. Yeah. Here we are gonna type how many class we have in our project. Okay, save it. In line 110. What are we in here? Yes. In line 110. It should be here. Fine tune checkpoint. Yes. Okay. Now, in this string, we're gonna give the path of our model's checkpoints. I mean, go to object detection, find your Thesis Inception v2 Coco file, open it and let me check. Yes. We are going to give the address of this file, something like this, and we're gonna type model.checkpoint. Okay. Other lines, line 126 and 28. 126 input path and label map path. Our input path is right here. Where is your train? Your train records. You're gonna have to give the address of your train records here, and the label map is in the training folder. It's here. You have to give the address of label map.bbtxt here. Okay. Now, in line 132. Now examples. You have to give the number of your test examples. I mean, go to your image file, open test directory and check how many photographs you have here. I got 413 JPEG file here, so I've typed here 413, and now we are going to do the same thing here, just only one change is input path is test records path, and the label map path is the same path of your label map, not the pbtxt path. It's here. It is right here. It's in your training folder. You have to copy this address bar and paste it to here, like this. Okay. Now, if you got something like this, like these are in your training folder, delete all of these except these 4 folders: label map, graph, festivalcnn.config and pipeline.config. Okay, do not delete these 4 folders and delete others. Okay, this is your training pre-trained models checkpoints. Okay. Then in object detection directory, go to inference graph directory and delete all of these. Okay. Yes. Now to start training, type this command to your command prompt. Just copy it and paste it here and press enter. Then your model will start training itself. It will take a while, like this. You can stop it anytime you want. Okay, it puts checkpoints here in your training folder. In here, my last checkpoint is here. As you can see, this number is the last step, last checkpoint. How can I say last checkpoints of my model? I've trained it nearly 8 hours. When you're done with your training, open the command prompt again. Do not forget to activate TensorFlow 1 in CUDA environment. Do not forget to write your do not forget to set your Python path again, and do not forget to go to this directory using cd commands. Okay. Now, after doing all of this, type these commands. First, type this something else, somewhere else, maybe a notepad. There is some weight string x. Okay, we are going to change this 4x with our last checkpoint. I mean, copy this number, okay, and replace it with those x's. Then copy this command and paste it to your command prompt like this. Wait a while. After the command is done, your inference graph folder should be something like this. Then after doing all of these steps I have explained in my GitHub repository, type idle to your command prompt. Now we are ready to test our model. Open object detection image.py. We need to change something, some lines here. Yeah, this is first. Type your class numbers, I mean how many classes you have, and this is the path of JPEG file you have to test. You're gonna test. My path is here in validation image. I got some JPEG files. Yeah, let's test this. Let's test this JPEG file. Gerisi olmayan 2. Let us begin. I'll give my path here, and this is my test JPEG's name. Nice. We're gonna wait a while. We're gonna wait for a while until the program executes the Python file. Yeah, here is our result. Our model has found the sign. The sign is no entry in English. Let's test another JPEG file. Which one? Let's test this. Capture 2 JPEG. Run. Dun, dun, dun. Yeah, another successful result. Model has found all traffic signs in the photograph, as you can see. 1, 2, 3, and this big sign 4. Let's test another. Which one to test? Let's test this. This will take a while, of course. Yes, and there is our results. Give way. The traffic sign give way. The model works fine for now. I have only 4 classes in my model for defined traffic sign. I mean, you guys, your model is up to your own dataset. If you understand these steps well and listen to me carefully, you can design your own dataset and you can design a perfect model. By the way, I am pretending like you already know what is CNN, what is deep learning, what is machine learning, or something like this. The subjects like this. If you don't know what is the meaning of CNN or neural network or machine learning, you have to learn machine learning algorithms at first. It's better for you. What can I say? If you do not understand this video, try to read my GitHub page. Traffic sign detection using faster RCNN. I have explained step by step everything here. Do whatever I say here. Thank you for watching this video, and sorry for my bad English. This is the first time I'm trying to explain something in English. Thank you.